Good morning, everyone. Still getting set up, so give me a second. Also, maybe good night. I don't know what time you guys are actually watching this. Um, there we go. This should be set up correctly. Can everyone hear me? Assuming they can. I don't know if that's a good assumption. There we go. I have almost all of the chats open. I'm streaming on a few different platforms. There we go. Okay, so today we're going to continue what we were doing yesterday. Uh, Wearing some, you know, Stack Overflow merch. I got this a long time ago. I don't even remember who gave this to me. Maybe someone that used to work at Stack Overflow, but this was like 5, 6 years ago, so back when Stack Overflow was cool and hip and people were actually using it. And I mean, I feel like today no one's using Stack Overflow anymore. Can't tell if it's sad or not. It's more just interesting. Because I never asked a question on Stack Overflow. I was too afraid to. But based on reading the comments, you see the types of answers people gave. It's just like, how dare you ask such a basic question? This is a duplicate. This is a duplicate. I guess the new generation doesn't get to enjoy that aspect of things. But yeah, I guess now we have ChatGPT, and it sort of, I mean, it sort of messes up, not messes up, but it's a different, just different than, you don't really communicate with anyone, even if the communication, you got shit on for asking a question. Not great communication, but it was a nice thing to have where you actually talk to someone and ask them for questions and people work on those things. Like a lot of people enjoyed working on open-ended Stack Overflow questions. But I guess those people also could just move to GitHub and sort of answer questions there instead of on Stack Overflow. But it would be a weird world if, I guess, we don't ask each other questions anymore. Like why would I ever ask someone a question if I could just ask ChatGPT the question and get probably a better answer. I don't need to deal with like, oh no, I asked a stupid question or any of the stress or anxiety to do with asking questions. But it is a kind of a sad world where we don't communicate to each other for knowledge. Yeah, I mean, it's just, it'll be a weird, different world. And maybe there'll always be a place for people because, I don't know, sometimes, like, if ChatGPT and all these places are so good, why does anyone buy any books anymore? And I think it's just for their writing style or the way people explain stuff. Um, I don't know. I wonder in the future, will we even have books anymore? Or will it all just be ChatGPT queries? And why would I ever buy a book if I could just ask ChatGPT to give me the information that I want? But then on the reverse side, you could say that about uh, basically Google. And, everyone had all this information that are in every single textbook available to them, you know, even with Google for many, many years. But, people still bought books and people still bought textbooks. I guess ChatGPT, I mean, right now I'm just rambling and waiting for some people to join. Uh, Also, I'm just enjoying the rambling a little. Uh, Anyone have any questions, any thoughts, anything they want to talk about? I'll take that as a maybe. Well, let's get into what we were actually, planning on doing today. We have learning paths now. A learning path, technically, we only have a single one. We have calculus, we're planning on adding linear algebra and probability, and then like a general machine learning path and deep learning path, and we'll add in a lot of other fun stuff. For example, we're probably going to add in reinforcement learning, deep reinforcement learning, LLMs, a lot of ideas, a lot of things we need to work on. But for now, we'll start with calculus, because I think I want to start with it. So yesterday we solved these two. Today we're going to try to solve these two. So we have the quotient rule. And again, I've taken calculus a long time ago, so let's see how much of this I actually remember. So I know it's the top times derivative of the bottom plus the bottom, no, top times derivative of the bottom times the bottom times derivative of the top. Let's see. Let's read the question and then we'll start trying to do it. Implement a function that computes the derivative of a quotient of two polynomial functions at a given point using the quotient rule. Okay, so we have two functions. Okay, and then f of x is just g of x divided by h of x. Okay, so we're given this list representation, which would be I probably should normalize these questions because last time we did the product rule and it was the reverse order. Like this was 3. This was x1. This was x to the 2. Like it was flipped over. But I don't think it's the biggest deal. Your function should. Okay. Let's see. I think this question has a playground, and we can see sort of how things work. So let's say we had a function g of x, which is x squared plus 1. What's this? Oh, so okay, we'll do this. Yeah, good, cool. So quotient rule is the derivative. Yeah, okay, derivative of the first times the second minus. Why does this not seem familiar to me? I feel like it was the. Oh, shit. Images. I guess it is. I just remember it being different. Maybe there's multiple ways of doing it. I remember like the top times the derivative of the bottom times, or minus the bottom times the derivative of the top, all over the bottom square. Yeah, okay. This is it. Yes. So it's the top, or here they do derivative of the top. I like the top times the bottom, derivative of the bottom minus the derivative of the top times the bottom. I feel like right now, I mean that just there's a lot of random words and it's probably relatively confusing for everyone. So let's try and because I'm trying to learn and teach at the same time. So right now we have basically the quotient rule and we have some function. Just do it here. We have some function here. And we have another function here, and we're going to do g of x divided by h of x. But we don't want to know the derivative of that. So let's just take these. Just take a picture of these, and we'll work these out by hand quickly, and then we'll continue. Okay, so first we take the derivative of g of x. So g x, this would be 2x plus 4, and we did this by basically taking this 2, moving it here, subtracting that by 1, So that becomes 2x to the 1, and then we sort of do the same thing here. We take a 1 here, multiply times 4, becomes 4. Let's also get the derivative of h right now. Equals 1. Just take the 1, similar process. Let me know if anyone has any questions on what I'm doing, or if you guys get lost. So we have the derivative of g, derivative of h. Now we need to do basically we need to do g times yeah, we gotta do g times h, or g prime times h. This would look like 2x plus 4 times x plus 2. That'd be the first part. And this would be minus h prime. So that would be 1 times x to the 2 plus 4x plus 1. And that's just regular g. So now that we have this, we do all of this divided by h squared. All of the bottom squared, so that would be x plus 2 to the power of 2. And this would give us the quotient, but I guess we do all of this and we get the result. I'm trying to think. Interesting. I'm trying to think. I guess top I would know how to do. Let's see. Okay, yeah, so. And I guess my question is, how do I show this in, because we need to show it in, I'm assuming. Oh, okay, no, we just need to compute the value. Okay, cool. It's easier than the product rule one. Okay, so notebook mode is fixed, by the way, so it saves your information. Yesterday it wasn't really working perfectly. Let's say it's add a cell. Let's just edit it here. So we have g. I guess we need a derivative function. Derivative. And it will take in some function. We did this yesterday. So we have to think, what does the derivative do? So I think it was 4. Okay, yes, so this is coefficients. So we're just sending in the coefficient. So it's 4x in range length of f. Okay. Let's change it to I. I like it better. So the coefficients are basically 1, 0, 1, or 1, 2, or whatever it is, or so. Let's see, for I in range, let's think what we're trying to do. So theoretically, we're given a list 1, 0, 1. I don't need something this big, so we have some list. And that is the equivalent to saying x to the 2 plus 1. Or plus 0x plus 1. Trying to think how to take the derivative. Maybe I'll just do it. Okay, I might need to take a small break. I will be back shortly. I'm enjoying myself. I'll be right back. Sorry about that. Hi. Is anyone still here? Okay, so where were we? We're taking the derivative of, given a list, we're trying to take that derivative. So what do we need to do? We need to take, I want to do it reversed. So given f, pretty sure this reverses the list. Make sure, so the list, A, and I want A. Yeah, nice. So I'm going to reverse it, and you'll see why in a second. We'll have our f, take the f, get the derivatives. Now our first value will be, let's see, f of I times f of I times I. So it's just whatever what we're doing. So since we used 1, 0, 1, it's the same thing, 1, 0, 1. But now we're looking at it like 1 plus 0x plus x squared. So we're looking at it like this. And we're taking the first position and we're saying basically there's x0. So it'd be 0 times 1 plus, in this case, it'd be 1 times 0. And guys, let me know if you're getting lost with where I'm getting any of these values from. Plus 2x to the power of 1, which is the same thing. This would be 2 times 1. Let me switch this order so it's a little more clear. 0 times 1. No. 1 times 0. So basically this is the position. So it's at position 0, at position 1, at position 2. And if we continue this, then it would be 3, 4, 5, and so on. So that's basically what we're doing here. So we're saying, let's go df.append, because this would go do this, and then we could return df, but we want it reversed again. So we put it back into the right format. Maybe there's a probably more elegant way to do this, but this is how I'm doing it. And now what we would need to do is, let's go, we need gf, which equals derivative of g underscore coefficient. I'm going to spell that wrong, so we do it like this. That's g, then we have h, wait, what? No, d of g, derivative of g, derivative of h. I don't know why sometimes I don't know, just make random mistakes, but I think everyone just makes random mistakes sometimes. Someone asked me how could I remember all these stuff. I didn't remember all of this, to be honest. Some of the stuff I remember, that's why I have the learn section here. I sort of remembered The quotient rule, I feel like, I don't know. I took AP Calc a long time ago, but I feel like I had this equation burned into my memory. But the point of the learn section is you're not supposed to really remember all these things. It's more like you read something mathematical, and you try to apply it, and this way you sort of understand, the math foundations by reading it, and then you're also able to apply it, so you learn the programming needed for it as well. But yeah, I don't remember all this stuff by heart. Some of this stuff I'll randomly remember, and that's just from doing it a whole bunch. Um, yeah, and the more you do, the more you'll randomly remember stuff. Let's see. So derivative of this, derivative of h, I'm assuming coefficient. Okay, so we have derivative of each. I wonder if I'd be able to just take the derivative. No, I wouldn't. Okay. Don't worry about it. It was a bad idea. Now what do we do? It's, let me just look over here, I guess. It is so it's g prime, so it's dg times h coefficient. Oh wait. Trying to, darn it. Because we actually need the values itself. So right now I'm just computing the, so all of these, so to get the value of the derivative, I need to add in the x value. So for I in dg, trying to make this out a little bit, and then I'll let you know what I'm thinking. So we'll take each value of the derivative. So this, let's say, find range length of dg. Am I gonna have to reverse these? Okay. Let's change this up so it also includes x. Pass this, and we will also pass a value x. X will be a value, so this just could be times x. And then this should be the sum of df. Let's see if that actually works first before we start. What function was I using? Or what did they use for the example? Whatever. Let's just see if it works. Do 1, 0, 1. B will equal 1, 2, 1. And we'll have a value of x equals 2. So let's think about what we're doing. So A is 1, 0, 1, which is equivalent to x squared plus 1. So if we take the derivative of this, this would become 2x, and then if we replace the x value into there, which we said I think was 2, so this would be 4. So theoretically, if we take derivative of a comma x, x is not defined. I mean, it is defined. Did I not run it? Okay. Oh. Okay. This seems to work. So we have the derivative of both of these. Now we need, I guess, to place in the regular values into. So into the x squared plus 1, we need to replace those values into, I mean, you have to put the x values into there. Yeah, we might do something like this. But we need it for, I don't even know what to call this. Get val. Gets the value from the function, so it takes an f, and the difference would be this, no, what's that? It's f of whatever, so that's the coefficient. So that's the coefficient to begin with. So that's the one, like in this sample 1, 0, 1, that's the one value. And this would be times the x value. Why is this so? Okay. First value gets such a complicated thing. It seems, and that's why I feel like it's good to do these programmatically, because I could do this mathematically, but I don't really know how to do it programmatically, it seems like, so it's good to do it both ways. df.append f of I times x. I feel like it should be to the power of I. This makes sense. Because it started at 0. It should just be, okay, but this should be inside of here. So it should start at 0, and x to the power of 0 is 1, and this would just become fi, which makes sense. Then let's say it's the second case, now this equals 1, so it's just x, so it's x times this, which makes sense, and then squared. Okay. I think this makes sense. I don't know why I'm, just say, it shouldn't be called df, but I could just do df plus equals this. I don't need to actually do it. Okay. So this will get us the value of a function when we plug in x to it, given that it is, they give us this, basically a list of values, and we're plugging in x into it. So back to this. So we did d of g, so let's do regular g. And it will take in the same thing. And then we will do h, get underscore val. This should do, take in these values. Okay. Now we do, I think we've just returned at this point. Turn derivative of g times h minus the derivative of h times g all over h squared. You think this will work? Let's see. Okay, let's see how we did. Why are you getting upset at me? Oh, I guess I don't need that. Okay, let's submit the answer. Let's see. Did I get anything wrong? I'm assuming I got something wrong. Just thinking about it for a bit. There's probably a few test cases. Taking longer than usual. Oh, I got a bunch of things wrong. Cool. Expected. Actual. What did I get right? Okay, I got this case right. Let's get a hint. N times a times x minus 1. But I implemented I. Oh, did I not? No, wait. I don't know if this is correct. I mean, that's the issue with generated hints, is sometimes they will be incorrect. But let's see. It's saying I did. It should be x to the. Oh, it should be x to the power of. Times x to the power of. I? Because I is basically minus 1 equivalent. Let's see. Because I guess I'm not. So the first case it would be 0, and then it would be 1, and then it would be 2. But if it's x minus 1, then it's. Okay, so that's I minus 1. But in cases where I don't think this is, because in the first case when it's 0 it's going to be x to the minus 1. I don't think that's right. I can just run these. Oh, okay. Might actually be right. Let's see, submit. Blah, blah, blah. Let's see. So close. Divided by 0 cannot be the power. Oh, x is 0. Okay, so I mean, if x is assume HI is not a so this would be x squared. Let's try to do this by hand. This would be okay. Gotta go. Hold on, sorry guys. Sorry about that. My baby threw up a little bit on my wife, so she needed my help for a sec. Where were we? Okay. If we did this by hand, this would be x squared plus 2x plus 3. And if I put in x is 0, this would be 0, this would be 0, this would be 3. And nice twin. Does the description not say? Because let me see what this thinks. Because I feel like. I guess what I don't understand is this is x squared plus x, so that's 0. So if I take this and divide it by this, I'm going to be dividing by 0. It should probably say return -1. Going to, I want to see the solution, but I'm going to submit this. And then I'm going to check out the solution. No, submit. Fine. Submit. You happy? There we go. Nice. So fetch those three. I do want to look at the solution quickly. Because I want to know, are you supposed to put -1? Well, I did them into numpy arrays and then, okay. I didn't know that was a, cool. Okay, I guess you could use some numpy functions and it would have been an easier problem, but you live and you learn. Okay, let's try and finish this section. X seems like it's being extra slow today, at least for me. I don't know for anyone else. I do need to fix this. This is a day off. Today is not Saturday, today is Friday. It also is missing the fact that I need to fix the progress thing. Sorry about that. Let's see. Yeah, X is just not working. Let's see with this function. There we go. Implement a function that calculates the magnitude and the direction of a gradient vector. Given a gradient vector, which could represent the gradient of a loss function with respect to parameters, compute magnitude L2 norm of the gradient vector, indicating how steep the function is at that point. Direction, the unit vector pointing in the direction of the steepest descent direction, the unit vector pointing in. I feel like this should be a medium question, but let me continue. So do we have a playground? We do have a playground. So, well. Okay, let's see. So given, I guess, we have a list of gradients, g of x and g of y. Let's see, when I change x, it moves it like this. When I change y, it moves it, yeah, that makes sense. Descent, I don't know how helpful this one is. Maybe I need to fix up that playground as well. Oh no, fine. Descent direction, unit vector points in the direction of the steepest descent. Let's read through this. Machine knowing the gradient function. Okay, get partial derivatives, coolsies. I'm trying to think if we should make this a little easier, like, I'm trying to think how. Okay, compute. What are we given? Given the gradients. Okay, so just do this to get the gradient magnitude. What's the final output supposed to look like? Dictionary of magnitude, direction, and descent direction, which is just the reverse of that. Fine. And I guess this is useful because in machine learning, usually using descent, which is the negative of ascent. So let's see, let's just make a dictionary. I think we might be able to just return it altogether. Let's see, return. I'm not even gonna try to spell stuff. Okay, the magnitude is, let's go, sum of gradients power 2 let's make this a numpy array. Sum all of that up, and that will give us the magnitude, square root. So sum that within a square root. That will give us the magnitude. Okay, what's next? Direction. Let's show off the tutor, because I think the magnitude is like how long it is, for lack of a better word, or how strong it is. But let's see if they have a better explanation. How steep a hill is just the length of the vector. So, okay. Okay, big magnitude is a very steep slope, small magnitude is a small slope. And what that would look like, my A+ drawing is, let's say, here would be a high magnitude because it's very steep. Maybe here would be a very low magnitude because it's not steep. Yeah, and I mean, same thing here. So this would be low here, but then if I go here, then, you know, it's a higher magnitude. We're just measuring the slope. Okay, I'm just measuring how steep the hill is. Okay, so we did magnitude, direction. What do they mean by direction? Let's break this down a little bit. We won't do it all in one messy function. Let's go here. D will be direction, and that will be, turn this to an array, gradients, divided by m. That should be, yeah, a list. So this should be m, comma, direction. Okay, maybe it should be an easy question. Direction, quotation marks, and this would be D. And then we would have, this is here. There's a gradient descent direction. And that would be minus D. I think I can make a better playground for that, though. Let's see if I'm right first, and then I'll say if it's an easy question or not. Okay, almost all the things right. I'm assuming this is like an edge case. If m equals 0, so we don't want to divide by 0, d equals 0, else we'll do this, d equals that. And that should be correct, I hope. What did I do? Oh. This should be... Oh, well, I guess... If that equals 0, then I guess the values actually have to be 0, so... Just do this. I can do zeros. I can do NP zeros with the length of the gradients, but I know the gradients are going to be 0. The only way to get... Is it going to be annoying like that? Fine. Fine. 0.0. Should I fix that? I'm trying to think, should I fix this or let everyone struggle with this? Maybe I should fix it. You probably should fix this. Let me just fix this, because this is annoying. I'm just going to do this for now, and I'm going to leave a comment to fix this later. I feel like this should be the output. Request specific changes, test cases. No, I don't think. Okay. General feedback. The result for test case 3 should be what? Embed operand. Oh. Ugh. Turn. Just do it like this. So I don't need the else anymore, which is nice. Yeah, okay. Not bad, not bad. Not all annoying. But we got it. It's Groundhog Day. Nice. We finished the first section. On to section 2, multivariate calculus. Let's see what's in it. We do partial derivatives, chain rule, Jacobian matrix, Haitian matrix. This is going to be an intense one. I think that's it for today. Anyone have any questions or thoughts or anything else? I'll take that as a no. Thank you guys for joining. Thank you guys for watching. Have a good day. See ya.